Assalamualaikum sir, I'm Mohammad Abra Jain and this is my video submission for milestone 2 of my Android Android app Robo Remote. So Robo Remote is designed to be a universal configurable mobile controller for custom robotics. The problem with existing controller apps is that they are usually hard coded for one specific robot. If you change the hardware, you have to rewrite the app. Our solution is a database driven architecture where button mapping, joystick configurations, and macro commands are stored in profiles. This allows a single app to control a drone, a rover, or a robotic arm simply by switching the active profile. In this milestone, we focused on three key areas: modernizing the tech stack, designing the backend architecture, and implementing the core user interface. So, mm, so if we go from our code and for UI, firstly I should I should clarify that I am using Android Gradle plugin and Kotlin for my application and Jetpack Compose libraries. So for the UI, we have moved away from legacy XML layout entirely, and we are using Jetpack Compose, which is Kotlin first and declarative. Here in the main activity, we have set up a navigation graph. This handles the routing between login screen, scan screen, and dashboard screen. This part. This handles the routing between. Achha, okay. This structure makes the app highly modular. If we look at the login screen, you can see how we handle state. We use remember and mutable state of to handle the email. Mm, it's right. Remember and mutable state of to remember the login mails and passwords. Finally, in the dashboard section, in the dashboard screen section, we are preparing the groundwork for hardware communication. We have set up the UI components, sliders, and joysticks to capture float values right now. These updates are internal state, and in the next sprint, and I mean the final part of my project, I will be implementing the trigger and the Bluetooth GET characteristics. So if we run the project, this is the basic layout of the application, and as it's a demo mode, I have not implemented yet the email and password, the verification system. It will be implemented in the final part. So if you go through the main dashboard, firstly, this is for selecting our devices, and it's just the demos here, the the multiple types. It's a This one is a Bluetooth based robot, this one is a ESP Bluetooth communication, and this one is a living room TV, or just a random Bluetooth from a device, from a random device. If we select this one, in the main dashboard we can see we can see a responsive interface. The slider is for limiting our speed, for like if we run our rover or a car, or a remote control car for example, we can limit the speed using this limiter bar. And below is a directional joystick, it's an omnidirection, and it calculates the x and y coordinates of from its center and gives the value accordingly to the robot. Currently, this verifies that our touch handling and coordinate mathematics are working correctly, which is critical for smooth robot control. And in our next part of, or the final part of the uh, application project, we will replace the mock data with Bluetooth get callback methods to scan for and connect to devices. Like this won't be only the only some pre-built data. It will take real-time Bluetooth data from its surroundings. I have also used Firebase for bypass and authentication. So we will remove the login bypass and authenticate a real Firebase backend. And we will map the joystick coordinates as we just showed to byte arrays to send to microcontrollers. And why we use byte arrays as because it can be read by both Arduino, ESP, and other microcontrollers as well. So that's about it, and thank you for giving me time. Assalamu alaikum.